Hey guys, welcome back to chapter 17. In this video, we're going to work an example of a integrated rate law that is not first order. The following reaction is a second order reaction. AB decomposes to form A plus B. It has a measured rate constant of 2.25 times 10 to the negative second, molarity and seconds to the negative 1 are the units. If the initial concentration of the reactant AB is 0.95, what is the concentration after 25 seconds? So things to point out here, this is second order. So if I were taking a test, I would go to my equation sheet and I would choose the equation that looks like this. 1 over, let me make this a little bit prettier. All right, I would use the one that looks like this. 1 over concentration of A at time t equals rate constant K times time plus 1 over concentration of A at time 0. So I know to pick that formula because it's second order. So let's go ahead and take inventory of what we know and decide what it is that we're solving for. So I'm just going to recreate the formula up here. All right. Now we're going to take inventory of what we know. So we've got concentration of A at time t. We've got K, we've got T, and then we've got concentration of A at time 0. So it has a measured rate constant of, so that's our value for K, 2.25 times 10 to the negative 2. So 2.25 times 10 to the negative 2. And the units are molarity, seconds on the bottom of a fraction, or molarity to the negative 1, seconds to the negative 1. If the initial concentration of the reactant is 0.95, so that's the concentration of A at time equals 0, what is the concentration after 25 seconds? So that's our time piece, 25 seconds. So again, we're solving for concentration of A at time t. So 1 over A t. We've got our rate constant, 2.25 times 10 to the negative second, molarity seconds. Times 25 seconds plus 1 over concentration of A at time 0 is 0.95, 5 molar. Alrighty, so I'm just going to clean up the right-hand side of this equation. So 1 over concentration of A, and then I'm going to plug this into my calculator. So 2.25 times 10 to the negative second times 25 equals, so I get a value of 0.563. Take a look at my units here. I've got 1 over molarity seconds, so seconds on the bottom, seconds on the top, those cancel. I'm still left with 1 over molarity, and that's important because I'm going to add it to something that is 1 over molarity for the units here. When I add two numbers together, the units have to be identical, so that's important that we're left with 1 over molarity. But I'm going to plug this into my calculator. So I'm going to just take 1 divided by 0.95. And I get a value that is 1.05. Great. So I'm going to add these two numbers together. So 0.563 plus 1.05 equals 1.613, 1 over molarity. Okay. That's not my answer. That is the inverse of the concentration of A. I don't want the inverse of the concentration of A. I want concentration of A at that time. So what I'm going to do is I'm going to multiply by the inverse. You could probably cross multiply. You could just simply flip it upside down. So whatever mathematical trick you use that. So I just created a fraction on this side. So this is technically on the top of the fraction. This is technically on the bottom. So what I'm going to do is I'm just going to flip. So I'm going to write in a different color so you see what I'm doing. So if I flip the left-hand side, that becomes concentration of A at time t over 1. And if I flip the right-hand side, that becomes 1 over 1.613. And the units become molarity. So molarity technically was in the bottom of this fraction. And when I flip it, it turns to the top. Okay. So to get the concentration of A at time t, I'm just going to take 1 divided by that value. So 1 divided by 1.613. The concentration of A at time t is 0.62 molar. And then lastly, we ask ourselves, does this make sense? So we started with 0.95 molar, we end with 0.6 molar. That goes down, and it's actually a pretty big jump. So even though it was only 25 seconds, that's a significant decrease, which is also indicative of a second order reaction. I hope you guys found this helpful.